Okay, so picking back up with 10.3, we're basically still doing some square roots with everything that's going on here. The biggest thing is that when we get to 10.3, you're going to have basically some not perfect square roots that when you get finished, you're going to have some numbers where you have a little bit of some numbers you're going to have to break down. Okay, so one of the very first things we've got here is it's going to ask you just to simplify a square root that's less than 100. Square root of 75. And again, for these, you're not doing decimal numbers on this. Everything that you're doing on these answers, they should tell you that they want this in simplest radical form, which means, your basic four-function calculator is not going to go with it. If you've got the Texas Instrument, it's also going to not give you an answer that's in radical form. So if you've got the Texas Instrument, this is where you'd have to take the 75. And you can do it one of two ways. You can either break it down to factor tree till you get down to all prime numbers, which again is 2s, 3s, and 5s for the most part. Or if you get one like this, you take 75, that's 25 times 3. If you happen to start breaking it down and you run across a number that's a perfect square root, you can square root 25, which would be 5, and 3 is a prime number, so that would be the answer you're looking for. So that would be 5 squared 3. And again, if you were to take it and break it down with the 75, if you did 25 times 3, eventually you would get 5 times 5. You would have 3 times 5 times 5. There's your pair of 5s. You could take that 5 out so that you'd have your 5 and then your square root of 3. So depending on how you want to look at it and the way you want to do it, either way it's the same answer. It just depends on, sometimes people will see that number jump out at them, and sometimes it just depends on how you break it down. Sometimes when you break it down to where you get a perfect square root that comes out of it, sometimes you don't, and it just kind of depends on how you go through this thing and the numbers that you're looking at. If you had the square root of 80. Again, start breaking it down. And again, everybody's going to look at it a little different. Most people probably would do 8 times 10. If you do 8 times 10, there's no perfect square roots, so then just keep on going. With the 8, you've got 4 times 2. With the 10, that's 2 times 5. And since we're going ahead and breaking them all down, let's go ahead and take the 4 and let's go all the way down. So with the 4, you've got 2 times 2, and then you can bring down the 2. Let's just do it this way. I think this is the way most people would have done it. So if you break it all the way down with the 80, you've got 2 times 2 times 2 times 5. Okay, so there's a pair of 2s, so you can take that 2 out. There's another pair of 2s. Take that 2 out. And because they're still multiplied, if you take out more than one number, they're still multiplied together. The 5 would be stuck on the inside. So on the outside, 2 times 2 would make that 4. Square root of 5. So on that one, it's just breaking down the numbers that aren't perfect square roots, where last time in section 10.1, most everything was perfect square roots. Now, some of them were fractions, some of them were other different numbers, but pretty much everything that you had should have been perfect square roots. And then section 2, we only had just a few little odd and end terms on that one. It was going from rational to exponent, exponent back to rational form, and then we're back to the, I guess, non-perfect square roots here in section 3. Okay, so after they give you a few problems where you're doing numbers less, everybody okay with those? Anybody need one more that's less than 100? Well, okay. After they do numbers that's less than 100, then they start giving you numbers that are more than 100. Still the same thing. Just take the 245 and break it down. And if you're not sure exactly what it is, you know it's an odd number, so you can divide it, try by any odd numbers, 3s, 5s, and 7s. If you take, now, last number being 245, you know you can divide it by 5. If you do that, that would be 49. And hopefully that's going to jump out at you that if you've got 5 times 49, that's a perfect square root number. So if you square root 49, that would be 7. The 5 is a prime number, so that would just be 7 squared root 5. And that's one of those numbers that, even though it's odd, if you checked it, 3 wouldn't go into it. The only numbers you can divide into 245 would have been 5 and 7. All right, let's do one more of those. Square root 153. Again, odd numbers, so I would say try dividing it by 3. If you do that, 3 would go in 51 times. 51 is still odd, so that's what, 3 times 17? 17 is a prime number. Both of the 3's are prime numbers. So if you break it down, you've got 3 times 3 times 17. So you do have a pair of 3's. So you can take the 3 out, and that leaves a 17 on the inside. So when you're breaking down the non-perfect square root numbers, basically you're looking, it's to put in a Finding Nemo reference, you're looking for exit buddies. If you can find 2 of the same kind, that pair of numbers gets out. And if you happen to have a number that doesn't have anything, like the 17, it doesn't have an exit buddy, so it stays on the inside. Okay, so after they've given you, a few small numbers less than 100, a few numbers bigger than 100, then they're going to give you some variables mixed in with it. This one you're going to simplify a radical with an even exponent. And it may be that you may get a perfect square root number, you may not get a perfect square root number, it just depends on how they throw this thing at you. But you've got square root of 54 and then w to the 14th. And when you get this one, again, you can almost think about it in 2 different parts. That it's really the number itself, square root of 54, that you're going to break down. And then you're going to have the square root of w14 that you're going to break down. All right, with 54, if you start breaking it down, it is even. But hopefully, maybe you'll see that it's 9 times 6. And that way, if you do square root of 9 times 6, well, you can do the square root of 9. And make that 3. So that's a 3 square root of 6. And again, you can take 6 and break it down and make it 2 times 3, but you've got 1, 2, and 1, 3. You don't have any pairs of anything, so that part of it would be as far as it goes. The W14, and this is where I think we talked about this last time, we're going to kind of go through it, is that since this is the square root, to shorten this thing out, all we're going to do is take this 14 and then just divide it by 2. And whatever your exponent is here, just divide it by whatever the radical is here. If there's no radical there, or no root here that they give to you, then that's always a 2. 14 divided by 2 is 7. Everything went on the outside, so final answer would be 3W7 and then square root of 6. Now, and on this one, if this simplifies down to a whole number, everything goes on the outside. If it's not a whole number, we'll kind of get that part coming up next. All right, let's give you another one of those. Let's go 32y to the 16. So we're looking at square root of 32 and then square root of y to the 16. All right, 32. A bunch of different ways you can break it down. But if you do 16 times 2, that way you've got the square root of 16. That's a perfect square root number. So when you take the square root of 16, that's 4. And you've got your square root of 2. With the y, again, it's square root, so that's 16 divided by 2. So that would be y to the 8. And technically, I guess you could leave the answer that way. But most of the time, they're going to put the whole number, anything that you can take outside the radical, they usually put that together. So that would be a 4, y to the 8, and the square root of 2, that would go on the end by itself. You know, if you left the answer here, it should still be okay. It's just, that's not the way. Normally, they take everything that goes on the outside of the square root, puts it in front. Anything that's left over in the square root, they put that on the back side of it. Okay. So they give you some of those where, again, really the exponent part here with the variable should be easy because you're just going to divide it. It's going to be a whole number, and you're really working more on the number and just breaking it down. Still doing the same thing. Okay. No, because you did the square root of 16, right? That if you square root 16, that would be a 4 by itself. That if you took the 32 and broke it down, that would be 2 times 16. Okay. So if you go 8, 4, you got 8 times 4. The 4 would be a perfect square root, right? Or did you break it all the way down to the 2's? Okay. All right, so you've got 2 times 4. That 4 would be 2 times 2. That 4 would be 2 times 2. So you've got 5 2's. Okay. 1, 2, 3, 4, 5. Everything's got to be in pairs because it's still square root. So there's one pair of 2's, so that 2's out. There's another pair of 2's, that 2's out. And now you've got the 1, 2 that's left on the inside. Okay, there you go. And you do your 2 times 2 to get your 4. Okay. After you're doing the even exponents, I think next thing up is you're going to do simplifying with an odd exponent. So as long as you get 4 square root of 2, either way you go, doesn't matter. And that's kind of what we're saying is that if you break these down and you happen to go, oh, there's a perfect square root, then you can stop with that part. If you break it down, like she was saying, if she did 4 times 8, well, if you break that down and nothing really jumps out at you, you just break it down till it's all 2's, 3's, 5's, and 7's. And then you just go back and do everything in pairs. There's a pair of 2's, so I take that 2 out. Another pair of 2's, I can take that one out. That 2 is by itself, so it's stuck on the inside. So it's really just on how you want to do it. Whether you're, and sometimes it's just on how you break the numbers down. She said she did 4 times 8. Well, you could do square root of 4, but it's already kind of small, so we could break it down no problem. Kind of like if you were doing square root of 50. If you went with 5 times 10, 10 you can make it 5 times 2. So you could have 5 times 5 times 2. There's a pair of 5's. So you could take the 5 out, you're left with a 2 on the inside. If I was doing 50 and I was going to break it down, the first thing I would do is, do 25 times 2. That way, square root of 25, well, that's a perfect square root number. Go ahead and make that 5, and then you got your square root of 2. Same answer, just a little different way of breaking it down. Okay. Simplify a radical expression. This time it's with an odd exponent. Okay, so for this one, we're going to do just one variable by itself, because this is the one thing we haven't talked about yet. Everything so far, section 1, everything was even exponents. So far in section 3, everything's even exponents. If you do x to the 5 divided by 2, well, 5, if you divide it by 2, does it go evenly? Doesn't, does it? Now, here's where I'll do stuff a little bit different from the way the book would tell you. The book would tell you, okay, well, you do everything in groups. If you had x to the 5th, they would say, all right, well, that's x times x times x times x times x. Okay. You'd pair off, there's a pair of x's, so I can take that x out. You pair off that x's, you can take that x out. We've got 1 left over on the inside. And we've got 2 on the outside. So if we've got x times x, that would be x squared. Square root of x. That's the way the book's going to kind of start you off with it, which is an okay way to do it. And that's fine until that number is 51. You don't want to write 51 x's, right? Because that's going to take you forever to go back and do that. So here's kind of the way that when I'm doing these, this is the way I've always kind of taught it. And to make this as easy as we can, when you're doing square root of x to the 5th, go ahead and do 5 divided by 2. Go ahead and rewrite it that way. And this is where I tell people, okay, just so that if this number's bigger at 51, go ahead and take 2 and divide it into 5. Because how many times will 2 go into 5? 2 times, right? With 1 left over. So if you divide these, the whole number you get up here, this is the exponent that goes on the outside. Let's just say it's the outside exponent. Your remainder is always going to be your leftovers that's on the inside. So this one would be x squared on the outside. And on the inside, you're going to have 1 that's x to the first power. Or if it's just 1 power, you can just leave the power of 1 off. And that's where, to me, that one, especially, you know, some people go, well, that's easy because it's just 2 and 5 when we divide it. Where it helps out a lot is when they do something like this, where you're doing the 4th root of x to the 91st power. Now, we may be jumping a little bit, but sometimes they give you the easy step ones, and it's all fine because they're really easy. Sometimes it's easier just to look at the hard ones and go, okay, here's why it's a lot better. Because all you're going to do is you're going to take x to the 91, and you're going to divide it by 4. Doesn't go evenly. So we're going to take 4, divide it into 91. 4 going to 9 2 times. 2 times 4 is 8. 4 going to 11 2 times with 3 left over. So if they ask you to simplify this one, as long as you can remember that the whole number is going to be your outside exponent, and your remainder is always going to be your inside exponent. And then you don't really have to worrying about grouping things and putting stuff. And they actually talk about, when it gets to the bigger numbers, they tell you that you're going to divide it anyway, but they do it kind of different. So it's like, all right, if we're going to divide it, let's just go ahead and, because they tell you you're going to take this and you're going to rewrite it and do some stuff. And it's like, okay, that's great, but let's just go ahead and divide this bottom number and the top number. Let's just do regular division numbers where you're back to 5th grade math. So for this one, we've got 22 that's going to go on the outside. We're going to have 3 that's going on the inside. And the only catch with this one is, because it was the 4th root, just have to put a 4 right there. And usually that's the one little mistake that sometimes people will make. They'll get this exponent, they'll get this exponent, and if this is something other than square root, a lot of times people will just forget to put that one in there. They just forget to put the 4th root or 3rd root or whatever the root's going to be there. All right, so let's do square root of u to the 17th. And to me, that was the whole point of the section 2 when they talked about writing it from radical form to exponential back to radical. It was so that you could do this kind of a problem and see what you're going to have. So if you've got u to the 17 divided by 2, just do 2 in the 17. It goes 8 times with 1 left over. So again, that u is going to be on the outside. That's u to the 8th. That's the square root of u to the 1st. So again, that goes on the outside. This one goes on the inside. Now again, if it's to the first power, you don't have to put the 1. You can leave it off. Okay, so once they give you 3 or 4 of these, have any practice with this, then they take the next thing is they're going to just add on a number in front of it. It's going to be the square root of 81 and then y to the 21st power. So it's still simplifying a radical expression with the odd exponent, so they just put a number in front of it. And this one, it's just like the earlier problems. You're going to do the square root of 81, break that number down as much as you can. You're going to take the y to the 21 and break it down as much as you can. Well, square root of 81, well, that's a perfect number, so that's just 9. For the y, it's 21 divided by 2. If we check it real quick, doesn't matter how we get there. We know it goes 10 times with 1 left over. So for the 9, you're going to have y to the 10th on the outside. And then you're going to have 1y on the inside. Okay, so let's go 8v43. So we're going to do the square root of 8 and then the square root of v to the 43. Okay, with 8, really only one way to break it down. It's 4 times 2. And when you do that, square root of 4 is a perfect square root number, so that would just be 2. So then you've got 2 square root of 2. Okay, with a v43, again, we know that's the second root, so we're going to take 2 and divide it into 43. We'll check that. That's going to go 21 times with 1 left over. So that's v to the 21st, and you're going to have 1v on the inside. Okay, so with those two, this was our answer from the number, this was our answer from the variable. On the outside we had a 2 and then a v21. So that's 2v21 on the inside. You got a 2 and a v. So that would be the final answer that we're looking for there. It's almost like a part A and a part B answer that when you get finished with it, just go back and put it back together. You can almost kind of, if we separate them out here, here's the whole number part, here's the variable part of it back here. Or the radical part with the coefficient. Okay, and with the two variables. Oh, it's not going to work. Try that again. Let's go square root of 75. Let's go t to the third and x to the ninth. Okay, again, I would say just worry about the square root because you've got 75, you've got to break it down. Again, a couple of ways you can break it, but if you break it down as 25 times 3, hopefully that 25 is jumping out at you. If you take the square root of 25, that's just 5. And then you've got the square root of 3 that would go behind it. Now, here's one where if you can kind of get in a pattern with the variables, because it kind of helps out a little bit. With the t, we're going to do 3 divided by 2. With the x, you're going to do 9 divided by 2. And this is one of those where you want to kind of copy the same motion as you're going down. So for the t, you're going to take 2, divide it into 3. So we'll go into 3 one time, one left over. And for the x's, you're going to divide 2 into 9. Goes 4 times with 1 left over. Okay, and if you can kind of do those where you're doing everything on the same line, you're dividing, you're putting the whole numbers on the same line, your remainders, if everything's on the same line, then everything up here is what goes on the outside. So on the outside, you're going to have 1t and 4 x's. So we've got just the 5 by itself. We've got 1t, and we've got 4 x's. On the inside, we still have this 3 from the number. You're going to have 1t on the inside, and then 1x on the outside. So we've got 1t on the inside, and 1x on the inside. So if you, especially with the variables, if you can keep these lined up, everything that's your whole numbers that's on top, everything here is going on the outside, everything in the remainder, that's what you're going to have left over on the inside. And took me a couple of times doing it this way before I figured out, okay, if we'll just stack it up, everything comes out kind of nice and neat, and it's all kind of organized. The only thing that's not really organized is your number. That part, you just have to break it down. Nothing really you can do to shortcut that one. All right, let's give you at least one more of those. Let's go square root of 48y is 11. Okay, so we're going to do square root of 48 with the y. Basically, it's 1/2. With the z, it's 11 over 2. Because again, if you don't have an exponent, just remember that there is a 1 there. So it's 1 divided by 2, and it's 11 divided by 2. Okay, 48. There's 3 or 4 different ways you can break down to 48. You can do 2 times 24. You can do 8 times 6. All kinds of different things you can do. And again, it's one of those, if you happen to kind of know your perfect square root numbers, 16 is one of those perfect square root numbers. And it's almost, if you've got your list of perfect square root numbers, you know, you've got your 4s, your 9, your 16, your 25, 36. If you get a number like 48, if you just do a quick glance over here and go, okay, is there any one of these numbers that I could divide in there? If you can find the biggest one, you can kind of square root it without having to break it all the way down to your prime numbers. Square root of 16, well, that's going to make it 4. And then square root of 3. Okay, for the y's, if you divide 2 into 1, it's not going to go, right? So then you got your 1 left over. For the z's, you're going to divide 2 into 11. You go 5 times with 1 left over. Okay, so when we put it all back together, we've got a 4 on the outside. Again, these are what goes on the outside. We don't have any, we've got 0 y's, so no y's make it out, but we do have 5 z's that make it out. And then on the inside, we've got a square root of 3, we've got 1 y, and we've also got 1 z. Okay, so they just kind of keep adding layers onto it and keep on breaking it down, and breaking it down till you've every time this, add one more little step to it. Okay, and for the most part, other than the one part with maybe the variable part mixed in with, right, even that one, I think we kind of jumped ahead a little bit. Everything up till now has all been square roots. The last 2 or 3 objectives, they get away from square roots. And this is where you're going to simplify a higher root. Okay, we did one with a variable. We didn't do one with a whole number. So for this one, we're going to do the 4 through to 48. The biggest thing on this one is that when your index is 4, that's how many you got to have in a group. So now we got to have 4 of a kind to break this thing out. So this is where you're going to have to, and once you get past, really once you get past square root, you're almost going to have to take everything and break everything down into 2s, 3s, 5s, and 7s. So you really don't have a choice on this one unless you've just really good with memorizing some numbers. You're going to have to take everything and break it down so you've got all prime numbers listed off. So with 48, it doesn't matter if you do 16 times 3 or 2 times 24 or 4 times 8. Because it's 4th root, it doesn't matter because we got to take everything and break it down as far as you can. 16 would be 2 times 8, or you can do 4. You can do 4 times 4. It doesn't really matter. Either way you go. And with the 4s, you get 2 times 2, another 2 times 2. So there's all your prime numbers. You've got a 3 and 4 2s. Okay, but there's the key thing is, it is the 4th root, so when you find your exit buddy, now you're not finding 2, you got to find 4 of a kind to break them out. There's your 4 2s, so that means we're taking out one of the 2s. Because again, it's how many of a kind you've got. So we've got 4 2s, so we've got that 2 of a kind here. There's only 1 3, so it's going to stay stuck on the inside. And that would be the final answer you're looking for that one. Well, in this case, the index, the root they put here, that's telling you how many you got to have. That's how many exit buddies you got to have. So you got to have 4 of the same kind before you can take one of those numbers out. So once we got the 4 2s, well, since we got 4 of a kind, we've got 4 of a kind of a 2. So we're just saying, all right, we just got the 2 that we're pulling out there. Same thing. Let's give you another one here. Let's say we were doing the 3rd root of 32. If you take the 32 and start breaking it down, you could do 4 times 8. 4 would be 2 times 2. The 8 would be 2 times 4. And finally you get the 2 times 2. So if you look at all your prime numbers, it's all just a bunch of 2s. Okay. And again, depending on what your root is that they give you here, that's going to tell you how different your answer is going to be. In this case, we're looking for groups. We got 3 of a kind. Well, if you circle 3 of the 2s, that means we can take that 2 out. You're stuck with there's only 2 more. Well, to get another 2 out, you'd have to have 1 more. And since there's only 2, that's the max you can do. So the 2 on the outside's good. And you've got 2 times 2. Well, if there's nothing else you can take on that one, just multiply it back together and tell me that's going to be 4. Where if that one had been the 4th root, just kind of doing a what if over here. If that had been the 4th root of 32, we'd have had the 5 2s down here. If that's fourth root, you've got to have 4 of a kind. So you take out those 4, put that 2 on the outside, you've only got 1 left over on the inside. So it would have been that. So it all depends on what that exponent is, or what that root is as to how many you can take out. Once you've got 3, you take those 3 out, tell me that number, and then just go back from there and tell me what's left over. So instead of having 2 of a kind, now you got to have 3 of a kind. Yeah, so if we were doing third root, this would be your answer. If we were doing fourth root, that would be your answer. If you're doing fifth root, if everything goes out, it'd just be a 2 by itself. Yeah, so if it was fifth root of 32, you're doing groups of 5. Well, if you do a group of 5, that takes all of them out. So that 2 goes on the outside. There's nothing left on the inside, so that one would have just been 2. So what that exponent is, what that root is on the inside, you can take the same number, and depending on what the root is, every time you change the root, you're going to change the answer you're going to get. Now, the good news is they're not going to make you change. They're just going to give you one problem with one root, and then they'll give you a different number on the next one, and just keep going from there. All right, let's do one more here. Let's do the third root of, get you a bigger number. Third root of 250. Okay, and again, start breaking it down. Doesn't matter how you get there. With the 0 on the end, you can make it 25 times 10. 25 would be 5 times 5. 10 would be 5 times 2. There's all your prime numbers. So if we break it down, that's the third root of 2 times 5 times 5 times 5. Okay, and again, the key thing is this one you got to have 3 of a kind. Well, for the 5s, we have 3 of a kind there, so that 5 can go out. The 2 only has 1, so it stays stuck on the inside. Okay, and then the last thing they throw at you in 10.3. And again, we've already done this one, so we're going to go ahead and just put one more here. This is where they're going to give you the root that's something different other than just square roots, because we kind of jumped the gun just to help you see it. So if you've got the fifth root of u to the 11th, again, you're just going to take 11 and divide it by 5. Well, let it go 2 times with 1 left over. So u squared and 1u left on the inside. And again, they tend to show it a little bit different way of how they set that one up. They kind of go a whole different route of how they show those kind of problems, which to me, a lot of times people get kind of lost and confused in how they set that one up. So this one, it's a lot easier to see that part of it than I'm just dividing 5 into 11. The way they set it up, sometimes it's a little bit confusing on exactly what they do with it there. Okay, so that's 10.3.